So in our previous class, we have seen how to work with XPath and what are the different types of XPath and how to write XPath manually and how to generate the XPath automatically. And also we have seen some functions along with XPath like contains, start with the text and so on. And also we have seen OR operator, AND operator along with the XPath. So today we are going to see a few more options in XPath, which are basically called as XPath access. XPath access. Now in this, we have certain number of keywords are available. So by using those keywords, we can also use those keywords inside the XPath. Okay. Now let me just tell you what are those keywords we can use along with the XPath. So self is one keyword. Parent is one keyword. Parent, child, ancestor, and descendant, and we also have something called following and following siblings, following hyphen sibling, and we also have preceding, then preceding hyphen sibling. So these are the different XPath access we have, and we can use them along with the XPath. Now let us try to understand them. So very carefully, we need to pay attention on this. So first let us understand what is an XPath, how it is going to work. And then we will discuss each and every keyword. Then we will understand what are these keywords, okay? So basically XPath, by using XPath, we can traverse throughout the DOM, like top to bottom and bottom to top. So this is the flexibility we have in the XPath. So normally when you write XPath, it will directly jump to the element, right? So from that element, we can take that element as a basis. From that element, we can navigate to any other elements on the same DOM structure. Like we can navigate through top direction or we can navigate to the bottom direction on the DOM. So that is a flexibility which we have in the XPath. So for that, we use this XPath access. Okay, normally what happens is when you take an HTML, so let us say the DOM structure you have. So this is one node, here it is another node, and here it is another node. So like this, there is a DOM is there. So there are multiple nodes are there. Okay, so suppose here, when you based on some node or some particular element, we can make this as a base. From that element, we can navigate or we can find any other element which are available on top of these elements, like these elements, or by taking this example, or by taking this node, or by making this node as a base, we can also find the bottom elements of that page. That means XPath access, by using XPath access, we can traverse through the DOM structure, top to bottom and bottom to top. So this is the actual concept of XPath access. To traverse like that, we use certain number of keywords along with the XPath. And these keywords, we can call them as XPath access. Okay. Now let me just show you. First, we need to understand what is self, what is parent, what is child node, what is ancestor node, and what is a descendant node. So these terms are basically talking about the different type of nodes which are available in the DOM. Okay. So let us try to first understand what exactly these names are representing, and then we will try to use them practically in our automation script. Okay. Now let me just share a small document. Let's go to our presentation. Yes. Now if you just look at this page, and if you understand this, you can easily understand all the terms and terminology. Let me just maximize it. Okay. Now listen this carefully. So here, let us say this is our DOM structure. Like every number is representing a node in the HTML. You can just consider that. Okay. Or every number is representing some element on the web page or some element on the DOM structure. Okay. Now let me take one element and I can call it as a self. So self means what? If you can consider any of the node as a self node. Okay. So whichever element we are taking that as a basis, that element we can consider as a self node. We can call it as a self node. So just for representation purpose, I have I have made one node as a self node here. So you can make any node as a self node. Okay, so I take this as a self node. Self is nothing but the node itself is a self. Okay, the node itself is a called a self node. So other keywords or other terminology we need to understand based on the self node. Okay, now here we have a multiple terms. Like let us start with the self. What is the self here? Every node is a self node. Every node there itself, that node itself is a self node. Okay, and what is a parent and what is a child node? So whichever is node which is available, or which node in the sense we can consider that as an element. Okay, so whichever node which is there, the top of the cells, immediate top of this self node, that is called as a parent node or parent element. So now if I just consider this is a self node, this is a self node. On top of this, which element is available? Immediate element, third element or third node. This is called as a parent node. This is a parent node. And whatever element which is there in immediate bottom, right, after self element in the T structure, that is a child node. So here 11 is a child node. So parent and 11 is a child node. 3 is a parent node of this particular self node. Okay. Now, what is a ancestor and descendant? So ancestor means the parent of parent. For example, for this self node, what is a parent? 3 is a parent. Now, what is a parent of 3? 1. So 1 is a ancestor node of self node. So for the self node, which one is ancestor node? 1 is an ancestor node. That means the parent. So for self node, 3 is a parent node. For self node, ancestor is a, 1 is an ancestor node. But again, if you consider 3 is a self node, then for 3, 1 is a parent node. Okay. Similarly, when I consider self as an actual node, from that node, 3 is a parent, 1 is an ancestor. That means a parent of parent. Similarly, if I just look at the bottom side, what is a descendant node? The descendant node is a child of child. We can consider that as a grandchild. Okay. So if I consider the self is a main node, from that element, from that node, 11 is a child node. For the 11, 16 is a another child node. So for the self node, 16 is a descendant node. For the self node, 11 is a child node, 16 is a descendant node. Okay, so this is the terminology which we need to understand. So you can just consider them as elements, or you can consider them as a tags, or you can consider them as a nodes. Okay, so for the self node, 3 is a parent, 1 is an ancestor. And for the self node, 11 is a child node and 16 is a descendant node. So now we are clear about 4 terms: ancestor, descendant, parent, and child. Okay. Now the next one is a following. So following and preceding. So these are the two important. Following siblings. There are 2 things are there. Following and following. Self we understand, parent, child, ancestor, descendant. So now rest of the things. Following sibling, preceding sibling. So these are the 4 terminologies which we need to understand. Now let us look at the following and following sibling. So what are the following node? So when you consider this self node, from if I start from here, what is the following node? The following node is always representing the above elements. So if I just look at the self node, above this self node, what are all other nodes are available? They're all comes under the following node. That means when I consider the self node, so what are the parallel elements are there along with the self? 7 and 8 along with this parallel node. And if I just look at here, 4 is also belongs to 3 here, right? So if I consider self is a central node, for the self node, 4, 7, 8. Okay, these are the 3 comes under the following node. Following node means after the self node, right side, whatever the elements are available, which we can call them as a following nodes. Similarly, whatever the elements which are there in the left side of self node, we can call them as a preceding nodes. But actually in the DOM structure, it will show you like this. Suppose this is self node. Whatever elements are there in the upper position or the parallel position like this, all these elements are comes under the following nodes. And this side, whatever the other elements are parallelly here, and these elements, preceding elements are basically comes here. Okay, so these are the nodes. So all together we can call as a preceding nodes, following and preceding. Okay, so if I just look at this picture once again, by taking the self node as a central node, what are the following node? The parallel nodes along with the upper level nodes. They are all comes under the following nodes. And while taking the self is a central node, and the other side, what are all nodes are available, these are all comes under the preceding nodes, preceding and following. Okay, so simple, we can simply write, guys. Suppose when I say A, B, C, right? So let us consider B is a main node. So what is A called? A is a preceding, C is a following, right? Similarly, if I consider self as a main node, the one side, whatever is there, these are all preceding nodes. The other side, which we can call them as a following nodes. Now, what about the following sibling and following preceding sibling? So again, in the following nodes, there are some nodes which are equivalent nodes, or we can say parallel nodes. So I can say self 7, 8 are there in the one parent node 3, right? Under parent 3, self along with the 7, 8 is there. So 7, 8 are the parallel nodes, we can say. Okay, so in the following, whatever parallel nodes are there or parallel elements are there along with this element, we can call them as a following sibling node. So these are also following nodes, but again sibling in the sense that the parallel nodes. Now again this side, these are all preceding nodes or preceding elements. Among them, whatever the parallel nodes we have here, these are called preceding siblings nodes, preceding siblings. Okay, so these are the terminologies which we need to understand before understanding the different type of XPaths. And the same thing we have to apply, same concept we have to remember while identifying the elements. So what is the main purpose of this? The purpose is, suppose I want to identify some element here. This element I want to identify, and I don't have any attributes for this element. So then what you can do? You can identify the nearby element, either the 3 or 2 or 4 or self node or any of the element nearby that element. From there, you can navigate and find that element. So that's the main purpose of it. Suppose I want to identify 16th element, but I don't have proper attributes of 16th element. Then how we can identify? You can find any nearby element and write XPath to that element. From there, you can navigate to the actual element. That means we can start from any node and we can navigate to any other node in the same DOM structure. So that kind of traversing is possible by using XPath access. So this is the actual concept of XPath access. Now, based on this understanding, we will see one practical example. So I have also prepared a small table here with the description of each and every node. Let me just share that. Okay. So first one, child node. So what is the purpose of the child here? Access child that traverse all the child elements of the current HTML tag. So what is the current HTML tag? Means a source self node. And whichever the node you will consider, that is a self node. Wherever you start writing the XPath, that is a self node. So from that self node, it will traverse through all the child element. And when you're writing the syntax, this is a syntax. So this is a actual XPath which is pointing to the XPath element, self node element. Child keyword we have to use. Child : let me maximize it. Okay, child : and from this element, whichever the child element we have for this element, if you want to identify that child element, you can just specify the tag name of that element by using child keyword. So then what happens? First XPath will navigate to this element. From there, it will find the child element which is having tag name is something here. We have to specify the tag name of the child element. This is a syntax. Similarly, suppose I want to find some element which is not having any attributes, but for that element, there is one child element is available. Now I can make this element as a self element. And by using this element, I can find the parent element by using parent keyword, parent colon. And for the parent element, whatever the tag is available, we can specify the tag name. So this will able to identify the parent node of this particular node or that particular element. Then following. So what following will do, it will traverse all the elements that comes after the current tag. So once you focus on one tag, after the tag, whatever the other tags which are following in the bottom level, we can consider all of them as a following nodes. So for that, if you want to find those following nodes, first make one element as a self element, any element. From there, use following keyword, colon, and the tag name. So what is the tag name here? Whichever element you exactly want to identify, and that element tag name you have to specify. Now, sometimes there may be so many following nodes are available, but among those nodes, whichever the node you want to find out, we can specify the tag name. And if the tag name is there for multiple elements, multiple following nodes, then you have to specify one another attribute for along with the tag name. Same thing for preceding. So what preceding will do, it will traverse all the nodes that comes before the current HTML tag. So you can just make it as one element XPath, and above the element, before having this code in the HTML, above that element, whatever the nodes are available, whatever elements are available, we can call them as a preceding elements or preceding nodes. So if you want to find out any preceding node of this element, then we can specify preceding keyword, colon, the tag name of the actual element, which is a preceding element of this XPath element. And then following sibling, same syntax. So in the following sibling, again, we have to specify the XPath of the element, and then following hyphen sibling, colon. And here we have to specify the sibling element. And again, sibling tag and along with some attribute. If it is available, you can specify. Same thing for preceding sibling. So first we need to find the XPath of the self element. From there, we can use preceding sibling, colon, and here tag of value, attribute value. And similarly here, ancestor. So there is a self node. For that, there will be some ancestor node I want to find out. By using the self node, I want to find out the ancestor node. For that, you can say actual self element XPath. Ancestor is a keyword, colon, tag name of the ancestor element. Then it will directly go to ancestor element from the self tag, self node. Descendant. So this is actually child of child, right? So we can just specify self element XPath, descendant, colon, tag name. So in the descendant means what? The child of child. That element we have to specify here. Tag name along with some attribute. If it is available, we can specify. So by using this, we can navigate from one level to another level. Okay, ancestor, we go with only one level. Ancestor, the name itself is representing what? Parent of parent. That's it. That's the ancestor. If I just look at this picture, so we can say self is a node. And what is the ancestor of self node? One is the ancestor. But if I just look at the if I take the 11th node here, for the 11th node, who is ancestor? 3 is ancestor, but we cannot consider 1 is an ancestor because only one level it will go. Okay, if I consider 11 as a self node, for the 11 self node here, this becomes a parent. Now parent of parent is what? 3. So 3 is an ancestor node of 11. Same thing for descendant also. Okay, same thing for descendant also. This is applicable. Now let us see all this practically through automation code, how we can use them. And very advanced level. So these are all locators are very advanced level. Very rare cases we use these locators. Okay, it is also difficult to remember, but most important. Sometimes interview people may ask what are the different type of XPath accesses are available. So then you should be able to tell by drawing this picture, and you have to explain what is the self node, what is a parent, what is ancestor, what is a preceding, descending. You should be able to explain all these things very clearly. Okay. So now let's go to practical and see. And let me create a new directory for today, day 14. Right. So inside this, I'm creating a new Python file. I'll name it as XPath access. Okay. So once you created your automation code, let me just copy some piece of code. Like we have imported Webdriver module, service module by class. Then we created service object. And after that, we launched our Chrome browser. So here I'm just showing you one application. Let's go to this application. Okay, so now we can just look at this table. So which is having a lot of data. Let me just maximize this page. Okay, so you can just look at this. This is having so many tables, so many companies, grew, previous close, current price, change, a lot of things are there, right? So what I can do is let me just take one company here. Let's take India Tourism D. So this is the option I'm taking. You can consider any of the element as a self element, self node. Okay. So I'm just starting from here. I'll consider this as a self node. From there, I will navigate to multiple type of elements. I will navigate to parent, ancestor, child, descendant, following, preceding, following sibling, preceding sibling. So I will try to find out all the different type of elements based on this element. Okay. Now, first of all, let us identify the self element. So I'll consider this India Tourism D is a self element. Okay. So let me just inspect this element. Okay. So this is the element and go to the selector hub. So guys, selector hub is basically the disable their features yesterday. Okay, so if I just try to do this, previously it was showing all the options like this, like XPath, CSS, link test, everything. But somehow they have disabled features. And after maybe few days, so they will again enable those features. Okay. And after that, you can start using it. So for now, we can just write our own XPath and test it. That's the only functionality working on this selector. But if you just pay something, or if you become a pattern member, so then you will be able to access all the features from the selector. Okay, so for now, we can just write our own XPath and then which will identify the element. Only that particular functionality we can use here. Okay, so let me just write an XPath here and observe this carefully. And this is the XPath I have written. So now what happens? So this is the XPath which is exactly pointing to the element which I am considering here. This is a self node. So this is a self node, right? And even if you write the self keyword, I'm just writing the self keyword slash self, okay, slash self colon. So what is the tag name of this element? A is the tag name of this element. Now still it is pointing to the same element because self means what? The element itself is a self. So that element itself is a self element. So even if you specify the self colon, so this self is representing the same element, right? So this is syntax. So let me just use it. And here I'll say self keyword. So how to write that statement? Driver dot find element by dot XPath, the double quotations, specify the XPath dot. So I just want to capture the text. So I just use one keyword called text. So what the text method will do is whatever element this statement is identified, from that element, this text variable will capture the value or capture the text from this element. And then we'll store the text value in a variable. Okay, in a variable. So I'm just taking one more variable called text message. And then I will print that. I can say print text underscore message. So what exactly we are doing here? So we are finding the one element and capturing the text value from that link and printing the value. So let's execute. Okay, so somehow it is given error. So I think I have not launched our application. Okay, so there's a problem. So let's launch our application. Driver dot get. Okay, so here there is no value actually, only text is there. I'll tell you. So driver dot get, and here we have to open this application first. So here we don't have a get method. Okay, so in Java we have a get text method, but here we don't have get or get text method. We have just only text variable. Text is there. Okay, so here we don't have a value, just text is there. So what this text will do, which will capture the text value of the web element, store that in a variable, and then I'm just printing the value. Do we have value method here? No, we don't have that variable. Okay, we have only text. Clear, Rashmi? So we have only text, we don't have value here. So value means is a generic term we are talking about. So if I just look at this, so what is a text? We can call this a text value. Okay, text value is a single word we can consider. So what is the text of this element, or what is the text value of this element? India tourism D, right? So this is the actual text value. So that is the actual thing which will capture by using this variable, and we are printing it here, right? So let's execute one more time. Yeah, now it is launched our page, and let me close it. Yeah, now it is captured the exact value. So this is a value we are expecting. And after launching my page, let me also maximize this page as a driver dot maximize window. Right, this is the self keyword. Self is nothing but very straightforward and very simple. Whichever element we are trying to find out, that element itself is a self element or self node we can consider. And actually you don't need to specify this, but if you still want to use self keyword, you can write self : and what is the tag name of this element? A, right? The tag name A is specified. So this is how we can just use self. So now this element I'm considering as a self node, and you can consider any element as a self node. So from which element you want to navigate to other elements. So that is basically called as a self element. Okay, self node. So now the node itself is a self node. That's the reason I'm saying self : same tag, same element is it talking about. Now let us see the parent. Let's comment this. Now let us see the parent. So now let me just find the same element till here. Okay, so the same element. Just a second. So XPath, and this is our XPath. This is a closed and a bracket closed and double quotations closed and another bracket. Okay, so now this is the actual XPath of the node, self node, right? For that self node, what is the parent node? I want to capture the parent node of the self node. What is this node? Now let us look at the HTML of that page. Now if I just look at here, so I consider this as a self node. Okay, for this particular node, what is the parent node of this? So what is the parent node of this self node? What is the parent node of this self node? TD is a parent node, right? So TD is a parent node. So for this TD, right? So do we have any value in this TD? For the TD tag, do you have any attributes or nothing, right? So A is actually part of TD. So TD is a parent node of this element. If you identify this TD, what is highlighting here actually? It is also highlighting the same node, because A is also included inside the TD. So for A, for this element, TD is a parent element. Now I want to identify this TD based on the self element. How we can identify the parent element? Simply we can say : slash. First we need to say slash parent : so what is the tag name of the parent tag? TD, right? So TD is the parent tag. Now the TD, the parent tag, is not having any value, but inside this there is a child tag. So this contains a value, right? So when you write the XPath of the TD also, what this will give you when I capture the text value, the same value will be given. So now this is a XPath, parent colon ID I have written. Now let us try to execute it and see what will happen. So I'm just capturing the text. And then again, print text message. So now based on this self element, I have identified the parent element. From that parent element, whatever the text is there, which will be captured. But actually parent element is having any text here? No. That's the reason this child element text will be automatically captured. So which is a part of the parent element, because the parent element itself is not having any text, so that it will automatically capture the text of the child element. So now this statement will also return the same thing. Okay, now go back. Yes, now it is also returning the same thing. We identified the parent element, but parent element doesn't have any value. The child element is a part of the parent element, so obviously it will get the value of the child element. So here we consider this as a source element or self element. From there, we navigated to the parent element by using parent keyword. This is an example. Now, child element. How to navigate to child element? Comment this. Again, go to this page and I'll consider this as a source element again. From this source element, what is the child element of this? This is another important thing. Remember this. Do we have any child element for this? For this tag, do we have any child element? Inside this anchor tag, do we have any other tags? No. Right? So this doesn't have any child elements. So now what I will do is, I will first go to parent element. So parent is having any child elements? Parent is having any child elements? Yeah, TD is having one child element, which is A. That's fine. So now what I will do is, first I will go to the ancestor element. Okay, for that ancestor element, there are multiple childs are there. Look at this. So this is a source element and self element. For this self element, anchor tag element, what is the ancestor element? TR. This is the ancestor element, right? TR is a ancestor element. Now, if I just consider this ancestor element, for this ancestor element, what are the child elements are there? See this, for this TR, what are the child elements are there? These are all child elements. These are all child elements of TR tag. So what is this TR again? The ancestor element of A. For A, TR is an ancestor element. And if I navigate to ancestor element, from there, if I just look at the child tags for this ancestor element, there are 3, 4, 5 child elements are there. So because our parent element is not having any child element, right? So because A is not having any child element, that's the reason what I will do is, first I will go to ancestor element. From there, I will capture all the child elements of the ancestor element. So this is how I'll do that. So observe this very carefully. First, I will capture this text till here. Okay. Finally, we will identify multiple childs. Okay. So we'll use this keyword finally. I'll tell you. So here, this is the XPath I have written. So here it is started. And let me just close it here. Okay. This is the self element. So do we have any child of this self element? No, we don't have any child of the self element. Now what I will do is, I will go to the ancestor element and then I'll find the child elements of the ancestor element. Okay. So how to go to the ancestor element? What is the ancestor element of this child element here? A element, not TD. TD is a parent element. And I will go to an ancestor element, which is a TR. So how to navigate to it? We can navigate to like this, slash, observe this, slash ancestor. Okay, I'm using ancestor keyword here. Okay, so ancestor, OR, spelling mistake, ANCEST, ancestor, :TR. Now till here, what will happen? This is a self node. From this, it will directly jump to the ancestor node. So where are we now? We are here. This is ancestor node. Now for this ancestor node, what are the child nodes are available? So these are all child nodes of ancestor node. Now I want to capture the data from all the child nodes which are available in the ancestor node. Right? These are the childs of this node tr. Now how we can do that? Again, slash child : td. Okay, so first we went to ancestor tag. From there, we captured all the child tags which are available for the ancestor tag. Fine. What you will get the output here? It will go to ancestor tag. So inside the ancestor, these are all the child nodes. So each child node is having some text. Actually, this tr is representing the complete line here. The whole line in the table, all the complete row in the table will be represented. So all this data will be captured when you use text method. So let me try to use dot text. So now let us try to print text underscore msg. Then observe. So after that, I'll close my page also. So try your dot close. Automatically, I want to close. Yes. Now this is actually this is displayed the same element. We have done some mistake. What is the mistake we have done? Let me just check it. Yeah. So ancestor : tr slash child : td. Okay. So basically, if I write like this, observe this carefully. What is problem here is inside the tr there are multiple childs are there, right? So inside the tr there are multiple tds are there, but I have mentioned only one td here, right? But it is matching with multiple tds or multiple web elements, but here we have used only find element, right? So in that case, which element will be identified? Only one element is identified. What is that element? This td. And what this td contains? Same value, India tourism day. So this is a value only which is written. Got my point? So now I want to capture all the child node values. I want to capture all the child node values for this ancestor node. For that, what you will do? Instead of find element, use find elements. Because this XPath anyway matching with multiple web elements. When I use find elements, what happens? Which will return all the web elements, into this variable. So I will name it as, right? I will name it as childs. And we should not use a text method now here, because find elements, we cannot get the text. Only by once from the single web element only we can capture the text. So first of all, we need to capture all the web elements, which are basically child nodes, inside the variable. Now I want to count how many are there. Simply what you can do, length of childs. Length of childs I'm printing. So now execute. Yes, now you can see 5, it is printed. Now let us find out. So in the ancestor node tr, how many child nodes are there? 1, 2, 3, 4. And this is also 5. 1, 2, 3, 4, 5 nodes are there. Right? So we are able to find all the child nodes of this particular node. Because in the first element, whichever node we have considered as a self node, for that element, we don't have a direct child nodes. That's the reason what we have done here. We went to the ancestor node. So for this node, tr is a parent. This tr is present in which tag? So td. Td is a parent. This td is again present in the tr. So this is ancestor node. But for this tr, there are multiple tds are there. These are all the child nodes of this tr tag. So I find out all the nodes and store them in a variable. And then I find out the total number of childs. Okay, so we cannot say text method like this, because what is this childs? Childs are the elements, total number of elements. All the web elements will be captured into these variables. So if you want to get the text message of each and every child, again, we have to write a loop statement, then we have to get it. Okay, otherwise we cannot get. So if you have a one single web element, we can use a text method, which will capture the text of the single web element. But you have a bulk number of web elements or multiple web elements in this variable, how we can use childs.text. You cannot. Okay. So we cannot capture the text value of all the elements at one time. So we have to write a loop statement which will read each and every text value of the each and every web element. That's the actual logic which we have to implement. But that is not the case here. So our main focus is how to use XPath accesses. So later on, I will discuss what are all you are asking, how to find multiple elements, how to get the text, how to perform actions. So that is again different case. Okay. So here we are just finding how many elements we have captured. These are all child elements, right? So now this is returning totally 5 elements are there. Now comment this. The next one. So we have seen self, parent, and child. So the next one is ancestor. So next ancestor we already seen, but one more time. Ancestor. How to use ancestor? Again, take the same element. So this is the element I'm taking. Okay, this is the element I'm taking. And this is actually pointing to the self node, which is actually pointing to the self node. Which one it is? This is the one. This is a self node consider. We are considering that as a self node. From this, what is the ancestor node of this? For this, TR is an ancestor node. TR is a ancestor node. Okay. And I want to find this node along with the text. I want to find the text. Do we have a text value for this node? We don't have, but this is ancestor node, right? So how to first get this node? Observe this carefully. This is most important. I say slash, I mention ancestor, just like a previous example, colon TR. And will it match with the single web element or multiple web elements? Because for this self node, there is only one ancestor, which is a TR. So which is a single web element. And if it is a single web element, we can capture the text, right? If it is a single web element, we can directly capture the text. So I'm trying to capture the text here because it's a single web element and store in the text underscore message. And then here I will print text underscore message. Now what you're expecting here? Because the TR doesn't have any value, but what you will expect when you get the text from the TR? Basically, this TR is representing the entire row in this table because all the TD is representing table data. And if I just look at here, I'm moving cursor in each and every TD tag, it is highlighting the column values. When I put the mouse cursor on the TR tag, it is highlighting the entire row. So when I use text method here, which will return the entire row value as a text, because all these values are present inside the TR. And the inside the TR in the sense, these are the, again, nodes are there. So that when I get the XPath of the TR, when I use text method on the TR, which will get the text from all these nodes printed as a one message. Now let us print and see what it will return. The entire row data will be printed. Yes, now you can see this is the actual, the whole data, row data is printed here. A 358.35, right? So 3575 is 375.30. So all the values are printed. Because even though the TR itself is not having data, but still these child nodes are having data. So which are all representing one single row. So that is a value which is returned. So from the ancestor. So for this self element, TR is an ancestor node. Now we'll see the descendant node. Descendant. I'm taking the same element again. Okay, so descendant. So what is a descendant node? I remove this part. Okay, this is a self node actually. This is a self node. We are currently focusing on the self node. What it is? This TD, the first one. Okay. From this self node, what is a descendant node of this self node? So what is a descendant node I'm talking? Descendant node. Do we have a descendant node of this? Do we have any descendant node for this node? Descendant node. So do we have any descendant node for this anchor tag? So we don't have any descendant node. Okay. So again, what you will do is we will directly go to the ancestor node, which is a TR. For this TR, there are some descendant nodes are available. Descendant nodes are available. So what are those descendant nodes? Descendant nodes. For this element, what are the descendant nodes? These are all the descendant nodes. These are all the descendant nodes. Sorry, so these are all following nodes, not the descendant nodes. So above are all descendant nodes. So let us see what are all nodes will be identified. Let me just write it the XPath. So I say slash descendants. I'm saying descendants. So first of all, we need to go to ancestor, right? Because this self node doesn't have any descendants. The self node doesn't have any descendants. So first let me go to the ancestor tag, which is again TR. So for that, what you will do, you can say ancestor : TR. So this will go to TR, which is ancestor node. From there, I will go to descendant tags. I'll go to descendant tags. So I'll say slash descendant : So here I don't know exactly what are the descendants of this TR. So if I don't know what are the descendants of the TR, you can simply say star. This is matching with all the descendant nodes of this particular node. And let us find what are they and let us find out. Okay. So if you want to check this XPath, you can just copy this and try to check it here. And in the selector hub, I'm placing that XPath and see what are the descent nodes. Okay, we haven't closed the bracket, I guess. Just a moment. XPath is not correct. It is saying something we missed it. Okay. So slash anchor tag contains a text comma India tourism and this bracket is closed. Ancestor ANCEST spelling, if there is any spelling mistake which will not identify, ancestor : TR slash descendant DES. Okay, this is DES. C also there. So DES CENDANT. So this is actual XPath. Let's try to execute. Now observe this. It is exactly pointing to 7 elements. So what are the 7 elements? So these are the elements 1, 2, 3, 4, 5. Internally, there are 2 elements here and here. And if I write this descendant star for this element, what are the descending nodes are showing? So again, for this node, these are the descendant nodes. These are the descendant nodes. For this ancestor tag, if I just here, for this ancestor tag, these are the descendant nodes. It is captured. Okay, descendant nodes means below 1. So let's use this XPath and find out how many are there. Okay, we have already used this XPath. Let me just copy once again. There is a spelling mistake. Okay, so now, and these are the descendant nodes. So it will return again multiple web elements because there are multiple descendants are there. So I'll use instead of find element, I use find elements. So now keep one variable here. What is that variable? I will just define one variable called descendants. Okay, so now I need to find out how many descendants are there for this element. Simply you can just print length of descendant. So every descendant is a again web element. Okay, you can just print descendants. And if you want to write a simple message, you can just write number of descendant nodes or elements and you can say comma. Done. So now it is exactly giving 7 elements. So 7 elements are there as a descendant nodes. Similarly, we can say following nodes. Following nodes. For the same element, what are the following nodes are available? Okay, so again, go to ancestor element and instead of descendant, I can simply say following. Following. Okay, now exactly change the XPath also here. Instead of descendant, let's say following, and what are the elements it is pointing, we will see. Following. See this, these are the following elements. So only these are the descendant elements of this TR, and following elements are all these elements. The rest of TRs all comes under the following elements. So we can use this and see how many elements are there. Go back. And here the followings. Let's print this value. Okay, so now it is saying 719 total following elements, because so many TR, so many rows are there in the same table, so it is counted everything. So these are all following nodes on the same DOM structure, so it is captured everything. So descendant and following, again in the descendant we have descendant sibling, in the following also we have a following sibling, right? So now we will see what is, sorry, we have seen following, and also we have seen descendant following we have seen. Now we will see following sibling, and then we will see preceding and preceding sibling. So ancestor descendant is a different. Now we have seen just following, and after following we will see following sibling, and after that we will see preceding and preceding sibling. So 4 different combinations. So we have seen these 5 as of now. So now we'll see following sibling, preceding and preceding sibling. So following is already seen, 719 is written. Now we'll see the following sibling. So following sibling is a subset of this number, right? Subset of this number, because inside the following, whatever the nodes are siblings, and those siblings will be captured. So now let's comment this. So following sibling. Okay. So in this, in the following sibling, I'm just trying to write this, copy this code. Following sibling. Following siblings. Okay, so now I'll just remove this ancestor, all these things. So simply the same self element, I'm just taking only self element. So this is a self element or self node. For this self node, I want to get following sibling. So first we need to go to, because self node doesn't have any siblings, right? If I just look at here again, remove this, refresh the page. Okay, so where is our self node? Yeah, here it is. Okay, so for this self node, so we don't have any following siblings or following nodes, so we need to again go to the ancestor. From there we will start. So how to go to the ancestor first? So here slash ancestor :tr. So this will go to ancestor tag first, and from that ancestor I just want to get following sibling, following sibling. And in the siblings, again in the following sibling, so there are so many TRs are there. So just look at here, there are, let me just say star here for now, because I don't know how many elements are there. I simply say star. I don't know what are the siblings are there, so I simply say star. Now let us capture all the following siblings and try to find out the total number of following siblings. So when I run this, so this will give you following siblings of that particular self. So total it is saving 72 siblings are there. 72 siblings are there, but there are so many are there. I want to get siblings which are having TR tag. So you can just specify TR and just execute now. So it is again getting the 72 because all the siblings are having TR tag. So you can just say star or tr. So this is how we can just first go to ancestor tag. From there, because if you already have siblings tags or following tags for this element directly, we no need to go with the ancestor tag. Okay, because our self node doesn't have any following or preceding child nodes. So that's the reason we are going to the ancestor tag. From there, we are finding child nodes, descendant nodes, following siblings nodes, everything we are getting from the ancestor node. So that's the reason we went here from the self node. So there's a navigation. So 72 is there. So this is following and following sibling. Now we will see preceding and preceding sibling. The next one is preceding. Preceding. So what is the preceding nodes of the current self node? Again, the self node doesn't have any precedings, right? Its current node doesn't have any precedings. So again, we need to go to the ancestor. From there, we will try to identify the precedings. So again, go to this XPath. Okay, so till here. So I'll name it as a precedings and close this XPath. So this is the actual XPath. Okay, so let's copy this XPath and see what are the elements are matching. This is actually our self node. Okay, so for this self node, first we need to go to ancestor node. How to go to ancestor node? / ancestor : tr. So now it is pointing to ancestor node. So from this ancestor node, I want to find precedings. So I say preceding : so I don't know what are the precedings. So I say star. Now it is pointing to all the elements, preceding elements, right? So then I can use this XPath. This will give you all the precedings of that particular element. Go back. And here I will replace this XPath. And this is also written multiple web elements because it's matching with more than one element. So we can find out the size. Print length of precedings, then execute. Yeah, totally 251 is there. So 251 elements are there. 251 precedings are there. So among these precedings, again, I want to get only TRs. The precedings are having so many here. These are all precedings, but what are all elements are having TR tag? I want to get only those precedings. So instead of star, you can say TR. Now only you will get 12 elements. So for this element, these are all preceding nodes. And instead of preceding, if I say following, then the bottom rows are the following nodes. Now you can understand. If I just take this as source element, these are all preceding nodes. Before that, whatever is there, they are all preceding nodes. And bottom, what are the nodes are available? They are following nodes, right? So now let's go back to the preceding again. So inside the preceding nodes, I want again get the preceding sibling nodes. So simply can say instead of preceding -sibling. Now it is reduced. Now it is become 11. So one element is gone, which is not a sibling of this current element. So let's copy this. So this is a preceding. Now preceding sibling. Again, driver dot find element. Right. Again, this is also returning multiple web elements, right? So here by dot XPath and capture them into preceding siblings and then we count it. Preceding siblings. And now we need to find out how many are there and also print length of same variable preceding siblings. Let's execute. Okay, now it is giving 11 because we specifically say TR. So it is saying 11. Okay. So this is how we can just navigate throughout the web page. Even sometimes, even if you have some elements, right? So instead of tr and td and everything, sometimes you may have some element tags like input tag or anchor tag or select tag or img tag, whatever it is. Finally, it is an element, web element. So we can navigate through those web elements. So we can make one of the element as a source element or self element. From there, you can find another element. Right? Don't think that element itself is a self element. Which element we need to consider as a self element? That depends upon your DOM structure. Okay. So for example, let us say you have these elements 1, 2, 3, 4, 5, 6 like this. These are the different elements you have like this. Okay. So like this, you have some elements. Okay. So for example, I want to find this particular element. Okay. But this element don't have any attributes. Even this element is also don't have any attributes. Then how to find this element? So whichever the near element which is having here. So we can consider this as a self node, and we can just use ancestor option to find this element. Just tag name only we have to specify. We don't need to specify any attribute of the target element. So this element is also not having any attribute. So what you will do finally? Nearby element is this one. So make this element as a self node and try to find this element by using ancestor. Okay. Similarly, for example, this is a descendant element, not an ancestor. Okay. Now, for example, I want to find out this element. This is my target element. I want to find out. And this element not having any attribute. This element is also not having any attribute. And this also not having any attribute. Now, how to find this element? And this is having some attribute. So first we need to make this as a self node. For this node, this is a parent node, right? By using parent option, we can identify this element by using this as a self node. Fine. Suppose I want to identify this element. Okay, but I don't have any attribute for this element. And I don't have any attribute for this also. Then how to identify this element? So this element I want to identify. This is my target element I want to identify. And to identify this element, if I want to use a parent element, so this is also not having any attribute. But what else we have? This element is there. So this is for this element, this is a parallel element. Parallel element. What is we can call as a following element, right? So this element is having some attribute. So this element we can make it as a self element. From there we can use following sibling. This is also sibling because this is not a sibling, guys. Sibling means what? Both should be in the parallel. Okay, so yeah, currently it is parallel because for both of them, these are only one parent. So by using this element, make this as a self node and use following sibling, and then you can identify this element just by specifying the tag name of this element. So based on your requirement, you have to make the nearby element is a self element. From there, you can navigate through this entire DOM to find out the element. So that is the actual concept of XPath access. Guys, are you getting? So this is the main concept of XPath access. Okay. So the preceding and preceding sibling. So what is the basic difference between preceding and preceding sibling? So let me just explain one more time. Preceding and preceding sibling. A small difference you need to identify. Preceding and preceding sibling, right? Let me just go to this document one more time. Clear this. So preceding and preceding sibling. So in the preceding, you can find all the nodes which are above this current node, above the self node. These are all preceding nodes which are above the self node. But what is a preceding sibling? The above the nodes in those elements, some nodes which are siblings of this self node. Siblings in the sense parallel nodes. If I just look at here, 2 is above the self, 6 is also above, 5 is above. But again, 5 and 6 are in the same hierarchy. You can just look at here. Self node 6 and 5, both are 3 or 7, 8 also. Again, 7, 8 comes under the following because they are another side. So here, when I say preceding, 5, 6, 2, all three comes under preceding because these are the above elements of the self node. But when I say preceding sibling, again in the preceding, it will find out what are the nodes which are parallel to the self node. And what are the parallel nodes here? Only 5 and 6 are the parallel nodes. So that is comes under the preceding sibling again. Okay, so by seeing the DOM structure only, you will be able to understand this. Here, this is just like a picture I have created just for understanding purpose. But in the reality, if you see the DOM structure, you will not see all the nodes in this hierarchy level. You will see the top-down, bottom, or top-down approach method. So in the top, more elements are there. You can just look at here. If I just look at the preceding and following, it is representing side by side, right? But actually, in the reality, what happens when you say here, preceding, what is happening? Observe this. Preceding, see this, the above elements. So for this a source element, what are the above elements are there? These are the representing. But in the same way, when I say instead of preceding, I say following. When I say following here, okay, so now below elements are highlighting. Below elements are highlighting. So above elements are preceding elements, below elements are actually following elements. But in the picture, how I have represented this, side by side I represented because there is no chance of representing the multiple elements here. But again, in the preceding element, there are few elements which are parallel to the self element. They are called preceding siblings. Similarly, in the following also, there are some elements which are parallel to self element, parallel to self node. So they are called as following siblings. So this is a difference. Okay, in the picture, we cannot exactly representing that, but we need to just imagine and understand this. So preceding is the top elements, above elements, and the following is a lower elements. We can consider that. Okay. So this is all about x-axis options. Okay, I will share this document and once again go through the video and look at the picture and try to understand. Okay, so these are all about locators concepts, guys. And with this, we have done with the locators concept. I think this is a third session and all the locators are most important. But even though if you're not properly understood this, no problem, because we are not going to use these locators very frequently until unless you work with the very complex pages. And we can manage with the normal locators as XPath, relative XPath, absolute XPath, XPath with the normal functions like contains the text and start with, we have those functions, right? So and or and operator. So we can manage with those operators most of the times. And that's it. So these are all about the locators concept. And from the next session, we will see how to interact with the different type of elements on the web page, how to automate the actual test cases, various number of test cases that we will see. Okay, this is a fundamental topic. First, I need to identify the element. That's the first thing. Once you are able to identify the element, the second thing is how to perform the actions on those elements. So there are so many methods, so many commands are provided by Selenium WebDriver to perform the actions. And those action methods we are going to discuss in the next sessions. All right. So I'm just stopping here. So we will continue in the next session in the next.